Welcome to this little video that I made about my projectile motion example. And for this example, I'm using the Khan Academy forum to create computer programs through coding. It's not really my thing, but I'm trying it out and it's pretty cool. So in this example, it's a projectile motion problem, and we're going to watch how you can actually code for the numerical calculations to see, if you set up the variables a certain way, how high, how far, how long he jumps. And so I have this little cool dude jumping. And in order to do this, I just set up my variables. And in this case, the positive y direction is downwards, and the positive x is to the right. So it's kind of funky the way you have to put in the numbers, but if you just keep in mind everything you need to know, it works out if you play with it. So here, and also these numbers code for like little segments of the area. It's not necessarily in seconds, meters, and meters per second, but this would be like a proportion, or we can do like an imaginary seconds. And so anyway, in order to make him project, we have to make sure we set up the problem. And we had a condition that we said if the height, or the y, is less than or equal to 300 like pixels or something, then we can say this happens. So here we're saying the new y, so y final, is equal to y initial plus the velocity times the change in time. Well, we are already given the initial y. We put that in. We're given the change in time is 0.1, and the initial velocity is -49, which it's going to look like it's going up because we said acceleration, which is gravity. In real life, it's -9.8. But on this, we have to make it positive, make the velocity negative in order for him to jump up. And in this case, since it's projectile motion, we know that the only forces that are applied on him is the force of gravity. It's only one force, and it's -mg. And that's the only force that is on him when he jumps up, so he comes right back down. We also know that the final velocity, so here I guess we're trying to find the final time, final y, final velocity. And we know that he's not going to change in the x direction because I haven't figured out how to make him project on the angle yet, but that will be for the next video. So if t final equals t initial plus change in time, we can say that we can let the computer calculate for each of these variables and to calculate for the final y, final velocity, and final time. So let's let him project. So right here, you just press restart and he jumps up. And you can adjust how high he jumps, how fast he jumps by adjusting the numbers right here. So if we want him to jump faster, we can just change this to make it a little... Oh, if we want to make it slower, because it's negative, right? So that made him jump a little slower and a little less high as well. We change in the opposite direction. You can make him go pretty fast and pretty high. He even goes out of the box for a while. And that's it. So if you change his velocity, we can also change the rate that he goes. So we could say 0.70. And he goes really fast, really high. I don't really know why he goes below where he started, but I guess that's just something I have to figure out in the next video. But or maybe it's just like a mistake in the, I don't know, in this website, or maybe my calculations. But we'll just have to see. Thank you for watching, and I hope you enjoyed this little video.